Session 1.4, Organizing Categorical Data. Remember, we do have two types of data. First one is categorical. Second one will be the numerical. And categorical data is talking about the names or label, just like the color or the letter grade, ABC. That's categorical data. And we are usually concerned with knowing how often a particular category occurs in our sample. And we want to compare how often a category occurs. So we need to know how to calculate the percentage and the weights in this session. Why do we need to organize the data? If we have the raw data, it can be very messy. And it's hard to read and understand and difficult to see the patterns. So we need to know how to organize the categorical data. And organizing the data helps us to see the patterns. So the first thing we can learn is organizing the data is two-way table. What is a two-way table? Very common way to organize the data and displays results from two potentially related variables. So for the two-way table means they contains two variables. And it shows combination of the various variables. So let's look at this example for the two-way table. Two-way table. The following two-way table shows a subset of the youth with survey in your test. So you can see this is called the two-way table. The first row here, this is one of the variables talking about the gender. We do have the male and the female. And then look at the first column. This is the second variables. Whether or not the youth always wears a seatbelt. Okay, so first I want you guys find out the total. Okay, find out the subtotal here. Okay, so we could see not always wear the seatbelt. We do have 5 people. And then always wear the seatbelt. We have 10 people here. How many males in the survey? We do have 5. How many female in the survey? We do have 10. Okay, so you could add up here. The total number will be 15. It should be match the number when you add up the row and the column here. And we call this one the 15. This is called grand total. Okay, grand total. Okay, we do have the two-way table here, and I want you guys try to answer these questions. Okay. So, how many males who always wear a seatbelt? How many male always wear the seatbelt? So that would be 3. 10 in the sample. Here they're talking about the gender. So 10 female in the sample. And 5 people who not always wear the seatbelt. Who do not always wear the seatbelt. Okay, right? You guys know how to read the two-way table. Okay, one more time. Two-way table, they contains 2 variables. And the corner here, this is called the grand total. So make sure every time when you guys see the two-way table, you want to add up the subtotal and the grand total. Okay, based on this example, the two-way table, I want you guys try to answer this question. I'm gonna do the first one for you guys. What percentage of the sample are men? Okay, they're talking about the percentage. So first, we do have a total number of people is 15. This is talking about the grand total. And then you're gonna look at it. How many males are there? We do have 5 males are there, right? So we're gonna find out the proportion of the men, the number of the men divided by the grand total. So 5/15, which is 0.33. Okay, this is the proportion. And we want to find out the percentage, so we use the proportion of the men and times 100% here. So we do have a 33% of a male in the sample. Okay, try the number 2. Okay, what percentage always wear the seatbelt? Okay, always wear the seatbelt is gonna be 10 here. Okay, so 10/15. You should find 0.66666, right? So I get the 2 decimal space, so 0.67. And then this is the proportion of always wear the seatbelt. And then the percentage will be times 100%, so 67% here. Number 3, are the men in the sample more likely than the woman in the sample to take the risk of not wearing a seatbelt? So can I just look at the table and say, okay, 2 male not wearing the seatbelt and 3 female is not always wearing the seatbelt. So I cannot just compare the number with here. No, right? Because there are more females than males in the sample, right? We do have a 10 female and 5 males in here. So we can't just compare the number in here. So what can we do? We should look at the percentage of those who don't always wear the seatbelt in each group. So let's find it out. The percentage of the males who don't always wear the seatbelt. So we do have a 2 male out of 5. Okay, 2/5. And then times 100% will be 40%. Same idea for the female. Okay, we do have a 3 female and total number of females is going to be 10. So it's going to be 3 divided by 10 and times 100% here. So you could compare with the percentage and then answer these questions. So obviously, men in the sample are more likely than the woman to take the risk of not wearing a seatbelt. Incomplete data. Caution, even when data looks complete, crucial information may be missing. For example, given the data in the following table, which sport list is the most dangerous? So we do have a list of the sport in here, and then this is the number of the injuries. So by looking for the numbers here, and I would say, oh, basketball will be the most dangerous sport, right? If I only look at the numbers in here. So that would be my answer. But actually the data missing something important information. We need the total number of the players. They never mention the total number of the players. So we are missing some critical information in here. So we can't answer this question. So look at this table. We do have the sport here, and then we have the participants here, and number of the injuries, and then the weight of injury per participant. Okay, so this table will be more details, and then we should base on this table to answer the questions. The previous answer we say the basketball will be the most dangerous sport, right? But actually, if you compare with the participants here, this is not true. This is not correct. So how can we get the weight of the injury per participant here? For example, I would look at the weight of injury per 1,000 participants. So it should be the most dangerous sport will be the football. Okay, will be the football. So how can we get this number? We could just find out just like the proportion and the percentage. Okay, we're gonna use 451,961 injuries divided by the participant here. Use your calculator. So you're gonna get this number. And then since they want to look it out like using the 1,000 participant, so we're gonna use this answer to times 1,000. And this is how they got 50.78. Okay, so if the information is incomplete, we can't really answer the questions. Okay, sometimes we call this is a misleading data. Okay, misleading data. Okay, we do have the two ways table, and I want you guys try to answer these two questions. We do have a question 1 and question 2. This is the two ways table, so I want you guys try to add one more column and one more row in here to find out the total and the grand total. Okay, let's do it together here. Okay, you should first calculate the total here. That will be 50 here and 40 here. So this is gonna be 15 and 75. So added up, the grand total will be 90. Okay? And then the percentage of the cars is left hand. The percentage of the cars, so 15 divided by 90 and times 100%, which is going to be get the B, 16.7%. Okay, so try the next one. Okay, what percent of the males are left hand? So we do have a 15 males and only 10 of them are left hand. So 10 over 50. Okay, answer is going to be B. For these sessions, I need you guys know how to calculate the proportion and then how to calculate the percentage as well. And then make sure you guys remember the two ways table contain two variables. And you need to know how to find the grand total. That's it.